CGI for giving us the opportunity to do this workshop. We're really excited. And for everybody that's here, I really encourage you to just please ask questions or share your thoughts. Stick your hand up or just yell it out during this. We want this to be, again, not just us talking. We want an interactive workshop here. This is about education, right? Richard and I are going to talk about some things that our companies have been working on together. We don't have all the answers yet. We've identified a problem. We're working on solutions, and our hope is that this session here today will uncover some even better ideas. I'd love to do like a quick poll around the room. Who is working as a drone service provider right now? Okay. Who is actually developing hardware and software right now? Okay. Any professional licensed surveyors in the crowd? No? Oh, one? All right. And are there anybody who's from a general contractor or some company that's a little more as a user of somebody who's actually developing the technology? Cool. All right, thanks for that. Let's get into it here. So I kind of already introduced myself. I have one slide on Skycatch, but we'll let Richard introduce himself and talk about Hensel Phelps. We'll then talk about the challenge and the problem that we see, and then we'll go through how is that problem sort of being addressed today. We'll then compare that to a new way. How do we think that we might be able to address that challenge better, and then kind of talk you through the solution that we're developing together. We have some example projects for Hensel Phelps, so some good stuff, and then we'll Q&A at the end, but also, like I mentioned, throughout. Richard.
Hello, my name is Richard Lopez. I am in charge of our drone program for Hensel Phelps. We have 8 districts, and we're in 2 different continents. We're celebrating our 80th year anniversary this year. So we are a heavy GC, general contractor. And we saw a need for drone use early on, really trying to understand how we could document our buildings better and actually safer and faster. That's the key thing, safer and faster. Utilizing the drone technology, it's just amazing. We're able to deploy a unit after we run our safety briefings and really understand what we're building, understanding the structure of a building, and understanding what issues we could run into as far as a safety aspect, and also understanding what we're physically building from the exterior of a building. Right now it's difficult to do that. We had to set up scaffolding, man lifts, personnel lifts. So there's several challenges. Using this new technology, we're able to achieve getting the information we need faster.
All right. And Richard, I want to say thanks to you, an amazing partner at Skycatch, and Richard drives UAV innovation throughout Hensel Phelps. If you ever have questions and you want to know how to successfully scale it out across a company or even just a couple sites and do it really well, talk to this guy. He's the best there is. Thanks for joining. Real quick, Skycatch, we provide an end-to-end drone data solution. It's a combination of hardware, firmware, cloud software, edge hardware, edge software, provide to industrial companies, construction, energy, mining, typically focus on large companies, scale it out across the whole thing. Our differentiators, in addition to being an end-to-end solution, we have extremely high accuracy with no GCPs, so somewhere between 1 and 5 centimeters. We're seeing with our new product we announced yesterday, Explore 1 drone, Edge 1 GPS base station and processing unit. Why are we talking about this today? As a company, we're expanding out of sort of regular horizontal or mid-tier mapping, and we're pushing ourselves into a new mode of going vertical inspection. We're going to talk about buildings today, but a lot of this applies to other things too, like I mentioned in the keynote. Wind turbines, cell towers, electrical towers. So this is an exciting stage for us, and we're just really excited to talk about something new. So Let's talk about the challenge. Every construction project has some liability associated with it after the project's done. Depending on the contract, it may be 5 years up to 10 years. The liability could actually basically vaporize the profits from the project. 10 years later, if you get a call that there's been water intrusion on a high rise, and it may have been sitting there for years, the cost of that alone could easily eat away the profits of the contract and more. Not to mention a damage to your insurance rating and your insurance policy. Richard, you have obviously a lot of experience with this. Is there anything you wanted to add to that?
Yeah, so this is really big. So when flying a drone on one of our projects, everything we do affects our bottom line, our EMR. And what that is, that's a rating within the construction industry. And if we have, for instance, what the example Patrick used, following the water. If there's a leak in a building, we're reliable for that. And it could be up to 10 years, depending on what our contracts are and depending on what the owner kind of negotiates. So being able to fly a drone and actually study the exterior of the building before we enclose it is a great opportunity for us to mitigate risk. Run a flare camera after we enclose it as well. That gives us the reassurance when we handed over a building to an owner that we did all of our due diligence to make sure that building was sealed properly.
Yeah. So today, companies like Hensel Phelps, they have a great process for horizontal surfaces. They have a drone program, they're mapping regularly, they have an archive, a record, it's all geo-referenced, good to go. But as the buildings start to go up, this overhead mapping doesn't have enough detail on the vertical surfaces. So what are we going to do about it? Well, let's talk about how it's done today. Richard can tell you about this example project. It's something that he worked on previously. We're going to kind of follow that through the thread here.
Yep, so this is an example of a vertical inspection we had to do. We actually went into this building here, J.J. Pickle building, 11 stories, and we physically replatted the whole exterior building. But our mission was to actually identify the cracks within the exterior of the building. We wanted to quantify that. So how we would do that typically, we'd actually start to erect scaffolding, personnel lifts, and get people up there to do that. So we then kind of thought outside of the box and thought, well, could we use a drone to actually achieve this? And we'll go through some of the examples here. But basically, we'll tell the story here a little bit more here.
Yeah, so I think it's important for us to point out what's the cost in dollars, the cost in time and use of your available personnel, and also the safety risk, most importantly. And so, Richard, why don't you run us through the cost?
And that's a huge thing, the whole safety factor of this. So when analyzing how can we accomplish studying the exterior of this building, we started looking at what it would take to actually get a personnel lift out there, to get out scaffolding, and how long it would take. So the process was going to take us about 2 weeks just to mobilize and start to really study the exterior of the skin. That's not including all the safety hazards we would have to actually go through and try to, and mitigate any type of safety factors. The way this building was situated, there were ledges, the wind, so there's so many safety factors that we had to take into consideration when erecting and really analyzing this building the traditional way.
So you guys were at, for this project, you would be at $4,500 per week for the lift.
Yep.
And you have to rent it basically for a week, is effectively
for about a couple of weeks for this project. So yeah, we would have been at that much for a couple of weeks.
Right, so $24,000 just in the equipment. And then even on a smaller inspection, is it accurate to say that if you were going to use a lift, you're still going to be spending $4,500, even if you finish it in a couple days, you're probably still going to rent it for a week?
Correct. Yeah, bottom line, yeah, we would have been spending that no matter what.
Yeah, okay.
And that's direct impact to the cost of the project. So again, we're trying to figure out how can we save the owner money as well? Yes, sir.
Do you factor personnel costs into this as well, or is that a kind of fixed cost of the facility?
No, that's, yeah.
It is. That's the next slide, actually.
Yep.
We'll hit that. It's a good question.
And that's a key thing here. So once we go through all the planning, it would take about 3 people to actually go inspect that. And that's one person actually doing the inspecting, a safety officer, and the inspector itself, the guy manning the lift. So a total of 3 people, but that's not including all the other logistics that went into this. So what we have here, we're showing some numbers here, but there's actually a little bit more involved there, a little bit more people involved, just to make sure that we're doing this safe. That's the key thing. We actually pride ourselves in doing everything safe, so there's a lot more time into this. So we're being really conservative on some of these numbers and kind of our manpower here.
Right. So what we came up with was, at a minimum, there's a safety brief for an hour. There's a setup time to get the lift in place and block things off, 2 hours every time you have to set it up. And then the inspection itself, that's a 2-week process for a building this size using this method, right? And then after you're done, you have to generate a report of the findings. That's another 2 days spent throwing photos into a box folder that's unorganized and it just sits there, maybe pulling a few out, putting them into a document and translating your notes from the inspections to that document. And in terms of getting things done faster, because the clock is always ticking on these projects, we feel this is really the equivalent of riding on a tricycle. And we want to get out of that mode. We need to accelerate, and we need to get from the tricycle to a motorcycle.
Mm-hmm.
Do you have anything on that one?
Yeah, and then keeping in mind here, this is just one project. We do several projects. So for every project, we have to go through this. And some of our projects, we're spending close to $50,000 to $100,000 just in scaffolding and lifts alone. That's not including our personnel. So what we're trying to do here with using drones within our operation is actually how can we save, one, the company money and also save the owner money, and also doing it safe. We still need to go through a safety briefing to make sure we're flying and we're compliant with all the rules and regulations. But if we're able to achieve the exact same thing quicker, faster, and safer, why not do that? And where this technology is going, it's truly amazing.
So this is the business case, right? And here's the summary on those costs. Just on this example, we're 24 grand on the equipment, 20 grand on labor, just the time it took to do it with all those people. So we're up to 44K total, and the safety risk is actually high. And I don't know if you have any, is there any more we should talk about with respect to like the specific safety risks of that method of scaffolding or personnel lift?
Yeah, so for every project we fill out, it's called an AHA, and it's essentially a risk assessment for every project. So with that, we brief every time we mobilize or move scaffolding or a personnel lift, we update that AHA and we brief everyone. So each time we do that, it's a cost essentially, because we're briefing everyone, we're remobilizing. But with utilizing a drone, we're able to actually fill out the AHA. We all understand where we're going to launch from, how we're going to conduct the operation, and what our obstacles are. And it goes so much quicker using a drone versus the traditional way. Not to say we're not going to do it the old way on some buildings. We'll still have to do it no matter what. But this will actually give us the information we need to make informed decisions quicker and faster.
Does anybody have any questions on that section? Setting up the business case, or why this is a good use of our time. It's going to help Hensel Phelps, it's going to help their clients, and it's going to help their team members be safer. No? Cool. So we think there's a better way to do this, if we haven't driven that point home. So on the equipment side, what's a better way? Obviously, we're talking about using a drone, DJI. I have an image of a Skycatch drone up here. Yes, you can use that to do inspection. You can use a lot of other DJI models to do it too. Just an example here. The drone kit, that number, not necessarily anything to do with the Explorer 1 from Skycatch, but just if you don't have something already, you want to get a full kit together with batteries and chargers and a tablet and all your accessories. Let's just say, in a zoom camera, let's just say $12,000 as a startup cost there. That's a one-time thing though, right? That's not much more than a few weeks of a personnel lift, but you got to keep spending on the personnel lift. Now you've got equipment, you've got capital, and you can use it as much as your company needs to. And then you probably want a software solution to go with that to help, and we'll talk about why, but to help the archiving and the analysis and the reporting. So example there would be Skycatch subscription for $200 a month, just an example. But you can already see, just on the equipment slide, and we'll summarize this later, our proposed better way is significantly less costly.
Let me elaborate on that one. So the drone kit. So when we flew that particular mission, at the time what we had available to us was the Inspire 1. So when you see that number, it's actually a kit. We actually, when we deploy on a mission, we make sure that we have everything we need to conduct that mission. I think for that one we had 30 batteries. We had a rangefinder, because that's another important thing. We need to understand, to fly safe, we need to understand what all the obstacles are. So we'll rangefy and document all surrounding buildings in our path of operation. And with that kit, we have all the extra iPads, the case. So that number there is actually a pretty true representation of what we purchased, because we've had the X5 camera with the 12 millimeter lens on it. So all those things actually make a big difference to conduct a successful mission.
Yeah, good stuff. So then on personnel. Yep,
so when we conducted that operation, we had the drone operator and we had 2 safety observers. And it went really quick, to tell you the truth. And I think the next slide is actually going to show us that. When we flew that, I think, go ahead and go to the next one. Yep. So with that, it took 2 days to conduct that operation. When we had it planned initially with the traditional scaffolding and personnel hoist, we were looking at anywhere from 2 weeks on up. And that's if we had good weather conditions as well, so that would have played a factor into it. But when we conducted that drone operation, it took us 2 days, safety briefing to understand where we're flying, how we're going to conduct our operations, making sure that we had everything cordoned off properly. So when looking at that, we saved a lot of time and money with that. And the key thing behind all that is making sure we're flying safe and just capturing the data. With that, we were able to run photos, we were able to run video of that. And keeping in mind, if we would have did it the traditional way, we would have relied on the observer and the inspector to really come back with that data. And if we would need to go back 2 weeks later and try to pull information from them about a certain location, we're relying on their memory to give us the information we needed. At any given time, we could go back and review all that data.
So it's a perfect segue into this section too.
So with that one, again, we were able to go back and analyze. Our goal was to understand the cracks within the building. We were looking for cracks that were a 1/16 to an 1/8 of an inch. And if we were able to, actually capture that data using the proper equipment, we were able to zoom in when we're flying the drone, able to zoom in, actually figure out where those cracks were. We were able to stop, photograph, and analyze that area a little bit better, would slow down, advance to the next one. So it did take us a while to do that. That was our biggest challenge, was trying to find a pattern or a rhythm to actually analyze what we were trying to document. Were we going to do a lawnmower pattern horizontally, where we're going to go up and down and kind of move over? So that was our biggest challenge, was making sure we were consistent, because once we established that, we had to do the exact same thing all the way around the building to keep that consistency. Yes?
In your previous slide, your 2 bullets said 3 person hours, and then one says automatic. What exactly was automatic?
So that's speaking a little bit ahead. We're going to talk about the solution we're developing to make that happen. When they did this, and it's actually, we're going to talk about that. You could talk about how you guys did that the manual way, what the investment was, what you came up with, but then how long it took. And
Yeah, do you want to talk about it now? Or
I think now's good.
Okay.
Yeah.
So what we did once we captured all that data, we needed a way to organize it because we had over 2,000 photos easily. So what we created a document because each photo had a GPS coordinates. So we were able to take those coordinates and then or transpose that onto a elevation of the building. With that, it was a hyperlinked document that we would actually look at the elevation of the building, figure out where the photo was because everything's geolocated. It had a hyperlink, click on it, and then it went back to the image of that particular area. So we were able to achieve that, but with that, it took us a long time just to put that document together because at that point, that was myself and an observer with me when we were flying. So they're relying on both my knowledge of when I flew that building and what area we're looking at. Because if you remember when looking at that photo of that building, everything looked the same on it. So that took a while, but it was an automatic PDF essentially. You click on each GPS coordinates and it takes you to the photo. So it took us some time to build that. Yeah, so yeah, looking at that photo there, it just, everything looks the same. So they're truly relying on me to make sure that I pick the right photo for the right location as well. Yes?
So using that manual method, how did you perform the scaling of the size of defect?
So with that, we were able to run it with some other software we have to actually analyze it. And it was actually, and we were looking for those bigger ones, you know, the 16th. And if we had a question, we actually went back and we did. And there was one location on the opposite side of that building. We actually took a personnel hoist after the fact just to go up there and verify because there was a crack there that we weren't too sure of. And it was actually at a joint of a building. But I mean, with the zoom lens, we were actually able to actually zoom in really close and we were able to kind of factor in like, okay, that is something we want to replace. So, answer your question?
Well, I wanted to make sure how you made a calculation based on either your
Yep, because
distance of offset, your zoom percentage.
Yep, so
how
that-
you're establishing
that background, yep, that background image that we superimposed, we actually created a CAD drawing as well because we had some of those documents. And with using, you know, Autodesk AutoCAD, right? We're able to actually superimpose and we were able to run some dimensions on that. So and that's what really helped us out as well to determine that. Okay.
Yeah. So wait, how long? So you manually looked at the exif on the photos and then placed a link to that photo on its location on this
Correct.
drawing.
Yes.
How long did that take you guys, like end to end?
You know, to develop that whole document, I'm thinking it probably took us another 2 weeks to develop that. And it was pretty much 2 weeks of just really focusing on that because we had to actually go all the way around the building to analyze it. So about 2 weeks to actually put that document together. So it took some time.
Yeah, so that's an investment in your personnel's time, time that they weren't working on something else, and also a delay for getting the results out, right?
It was
Reporting out.
it was a delay, and that was one of the things. On one of the elevations, we actually didn't get to right away, and we actually had the project manager on the phone calling us, where is this elevation? So there was a delay in that whole process.
Good stuff. So is there anything else you wanted to cover on this one, the protection or?
No, well,
Okay.
here's one thing also. Oh, question, go ahead.
Yeah, have you considered using the LiDAR scanner in the future?
You know, we have considered that, the backpack one, but the problem we had with those particular elevations, just really getting up to that location and actually finding those cracks. We ran terrestrial scans at the lower level to see if we could actually achieve that. And the fidelity of that, we just weren't getting that same fidelity to actually analyze those cracks that small, because if you're familiar with LiDAR, you get that point cloud. We weren't capturing it. So the photographs actually were a better value for us.
But if you did a facade scan with the LiDAR scanner on the UAV,
Oh,
close enough,
10-4.
you would be able to detect, cracks as small as 2 millimeters.
Yes, at the time, we didn't have that option, right? All I had with us when we flew that building was Inspire, but yes, to your point, that would work as well, yeah, running the LiDAR on it. Yep. Okay, and go ahead.
Richard, can you speak to your program in terms of, in this application, it's an external facade. Do you have programs for inside the building or other projects where you're talking about interiors or other GPS-denied environments?
Well, we are working with a company in California at some of our indoor big facilities. We are running indoor scans. And we're still beta testing it. Again, like what Patrick alluded to, there's no GPS in there, so everything's running off of sonar pretty much on that one. So we're still investigating that to see how that's going to work with us in the future. But once we figure something out, I'll talk to you about that. Yeah.
Please.
All right, good questions. Anything else on this?
No, I think we're
good. So to summarize here, just again, thinking about the business case. If we assume that the drone cost is a capital purchase and can be amortized across all of your inspections, really what's left is whatever you're paying for software, right? So just in this example, we said, okay, let's say it's $200 a month. If you do more inspections, obviously it's less per inspection. Your personnel cost is significantly lower because of the time savings, and you have less people. You're down to $3,000. So really, we're somewhere south of $3,200 per inspection here, and far safer.
Yeah.
Any questions on that?
Just because the genuine business case is really interesting to most people. When you look at the 45 grand versus 32 grand, safety considered, it seems more magnanimous maybe than it is. You mentioned that there may have been a go back, or so, or validate something. Did you use lift or scaffolding to do that?
We used a lift for that one.
So was there a weekly charge associated with that?
We were able to pull that lift from another project. So
You
normally,
variabilize that, but it wouldn't be the full 4,500.
correct, it wasn't.
And then for the humans, you mentioned like 1 to 2 weeks of processing. Was that an additional duty, or was that like if you looked at it from a man-hour standpoint?
That's an additional duty. It's an additional
Right.
duty for
So
that.
there's some burden you want to put on that. So,
Yes.
I mean, if you're really, if I'm trying to sell something like this to somebody, I'd want to say it's maybe not 12X, but it's at least 6X.
Yeah, and that 2-week processing isn't included in this cost because we're going to propose.
Yeah, it can't be. That's what I'm
No,
saying.
yeah.
It's actual real work.
Yes.
We'll propose that has to go away. That can't be. That's not scalable. You can't repeat that. We need to automate that, and we'll talk about how we're going to do that. It's honestly not that hard.
Well, I got one other question, if you don't mind. 'cause
Nope,
it's on
go right ahead.
the CapEx specifically. You may or may not want to say it, but how many sites are you actually able to take that $12,000 investment, plus logistics cost to get it someplace new, and use it so that your utilization rate really makes it approach zero?
So the 12,000 you're talking about the drone purchase, correct?
Yeah, like, I don't know how many
Yep.
drones you have, but
Yep.
what
So-
percentage of the week are they flying would be an indication of whether that.
So we fly every project. For example, our district here, we consider in Denver the Plains District. We fly all of our projects weekly. And with that, what we do is we actually have a document for each project, and we spell out what exactly we want to achieve. Is it orthomosaic? Is it vertical inspection? Crane inspection? We spell that out early on. So that's how we're justifying the cost of our drone, and that's spread out throughout our district. So we're flying a lot locally in the Plains
And you
District.
keep them in small geographic areas.
Correct, yeah. So, for instance, my district, I'll travel all of Colorado, Wyoming, New Mexico, Kansas City. So I'll travel in that region. But I have pilots in SoCal, NorCal. I have them in Florida. So each district has their own system set up in place, and we track all of that. And that's a key thing, is we track all that because I need to make sure that we justify the drone program to our upper management. So what we use Skyward to actually track all of our inventory, all of our flights, so they know at any given time that we are utilizing this equipment. And that's actually helping us move forward to purchase bigger drones, LiDAR units and all that in the future.
So that 199 include this Sky, whatever, service, to analyze the data, to store the data,
Yeah.
real time.
Correct. Yeah. Our next slides will kind of go over.
Also include a pilot too?
No.
No, it doesn't.
So you have to hire a pilot, outside pilot.
Yeah, or get a 107 yourself.
Yeah, we have internal pilots. At our organization, I have 12 pilots within my organization. that actually fly all of our different
And
districts.
how much the cost, indirect cost to follow, to comply with the rules, local rules, airport rules? Are you flying in the?
Yep, so how that works,
Downtown.
yeah, so the way my pilots operate, they have other duties as well. They're part of our virtual design and construction department. So those pilots, their mission is, as a pilot, is to understand what all the rules and regulations are. We have some projects within controlled airspace that I cannot fly until we get a waiver or an authorization. But once we get those authorizations, then we'll fly within that controlled airspace. I have some, a couple of airports now where we're able to fly, and again, it's like anything, you just coordinate with the air traffic control manager when you're conducting these operations. So our pilots are in charge of all that stuff. And again, they have other duties, but as being a pilot, that's part of their responsibility.
Okay.
Any other questions?
So if we don't have a pilot, then you provide a pilot?
We'll help you get one for sure. We work closely with some companies that provide pilots as a service.
And how much the hourly rate for that?
It depends on the size of the project, the frequency of the flying, where it is, what your output needs are. But we can talk after I can give you more details.
Sure.
Cool. Anything else on this one?
No, I think we're good.
So we kind of just talked through this in the questions, but again, just for the sake of today's workshop, we've made some assumptions. We have some example scenarios here to give you guys a sense of what we think the opportunity is in the business case. And we think it's amazing. We think it's a no-brainer. So as a no-brainer, even just from a safety perspective. So there's some numbers, right? So $24K each time, down to $12,000 one time for your kid, $200 a month after that. Personnel costs are from $20K down to $3. The time elapsed goes from 2 weeks down to a few days, and safety gets significantly better. All right. Any questions on that? No. So here's the solution that we're working on. This isn't released. This is in early stages. It's not even in beta yet. We're working it out. There's a lot of different ways actually that we've devised that we could potentially automate this process, right? We're going to go over one of those today, and there are others, and we'll iterate our way to the perfect solution and release it out to the world. Richard, do you want to tell us about this example project?
Yep. So this example project is actually right down the street. It's 1144 15th Street. It's a 43-story building, and it's a new construction mixed use. So with this particular project, it's truly challenging because we're within an urban environment, and what's crucial here and what's important is GPS. We've flown this several times, and we always lose GPS. So those are things to really consider when trying to plan out your operation. Is if there's a ton of interference, it's just going to be a truly sketchy flight. So you need to take all that into consideration.
And on this one, you have tall buildings right next to it, so the GPS signal just gets lost in between those buildings.
Correct, yeah.
You can't fly in fully autonomous mode.
Yeah, and it was challenging when we had to go back and actually do vertical inspections of all of our embeds. And using the drone that we had, it posed a challenge because we were actually flying with non-GPS the whole time. So we really had to take into consideration wind conditions, because that's huge when you're not flying with GPS and you're flying that close to a building. And we had to cordon off the streets. Luckily, when we took over this project, we actually took over some lanes. So we utilized that. And again, flying over people, we had to do it on a weekend. So there were a lot of challenges that we had to go through in flying this particular building.
So here's the solution that we're posing and that we're working out. Here's how it works. You actually do a quick overhead nadir map of the project, and you can do that anytime that you have an outline of the building. It doesn't matter how vertical it's gotten yet, right? You can use a map that shows you the outline of the building. And you're actually going to pull that into our flight app. You're going to trace the boundary of the building or the perimeter of it on the screen, set that up, And then you're going to enter what are the lowest and highest altitudes that you want to inspect. So sort of where's the drone going to climb to start, and how far it's going to go while it's taking photos. Richard, you have a little bit to add to that, I think, just in terms of sort of how you set these things up, right? In thinking about, you know, how many floors do you do at a time? What's the distance between them? Or how do you plan that in your mind?
So normally when we fly this, we really need to take into consideration our floor-to-floor heights. So this particular building, the first floor is 14 feet, then it goes to 12 feet at the second floor. Third floor is 14 feet, and then all the other floors after that are 12 feet. So when planning a mission, I'm running an inspection on that, I need to make sure that I'm circling, you know, each floor at each level. So what we'll do, we'll take the architectural drawings, the structural drawings, and actually figure out what our elevations are. And we manually have to go in there and kind of start clocking all that stuff, making sure we're at the proper elevation. So that alone in planning is time consuming, and when I'm flying this mission, I always have my cheat sheet with me to understand what elevation I'm flying at.
Yep, so we want to automate that in our flight app. So once you enter in those altitudes, we actually turn the display 3D. We actually, if you use Sketchup, you would be familiar with drawing a polygon and then extruding it vertically up to the height that's been entered, right? Then we actually render the flight path across that face. And you can see on the drawer there the third plus minus sign down. Ask the operator to enter the distance from the building that they want to fly. And that's a decision that you make based on safety, based on other elevators or other equipment there, other trees, and also based on, like, the question in the back was, you know, about what size of defect can you actually detect. This is just like GSD on your overhead mapping. The closer you are to the building, the greater resolution in your photos, and the smaller the defect you're going to be able to see. So we set this up with significantly less overlap than a Nadir mapping mission. Why? Because we're not doing 3D reconstruction. This is purely for 2D photos, for high res and inspection. We're not doing 3D reconstruction. We don't need to. Question?
Yeah, I interrupted you and I came in late, so maybe somebody already answered this. Since the rule is 400 feet altitude, your buildings are higher than that, do you pull a waiver, or are you allowed to go higher than that on any of your inspections? Most buildings that you're looking at are over 400 feet. How do you pull?
So we don't need to go above the building.
As long as you're within
the
law, it's 400 feet above the building.
The structure from the top AGL, from the top of the building, or from the ground?
From the takeoff.
Okay.
Yeah, so we're good question. We're a good clarification there. So we're good on that. Yeah, so there's a lot of parallels here to the regular mapping that you're used to in terms of the setup. Once you establish those things, so in this example, we're doing quite a few floors of the building. Draw the routing just like you're used to seeing. And when you hit takeoff, the drone's going to take off and start following those routes. Is there anything to add to this one?
Yeah, so typically how we would conduct an operation like this, again, this right here, this is really valuable. At the time we've done several inspections already of vertical structures. Our biggest challenge is always being a safe distance away from the building, making sure we're not too close. And with this system here, we're able to get that warm and fuzzy, essentially, of knowing that we're going to be adequately away from the building at a given time, and it's also locked in with the waypoints information.
Yeah. Oh, go ahead.
So there was a discussion about losing GPS on a regular basis in these flight profiles. So how do you stay on route when you can't trust your GPS?
Yeah, you have to use something else.
Okay.
Yeah. We have a couple sort of lessons learned and best practices to cover that. For now, we'll just assume that this building is, you know, the only one around, and the GPS is perfect.
So you guys not using a triangulation from the cell side then?
Yeah. Well, No, and I probably wouldn't trust that, but, yeah, so, but we'll get to that.
Well, I have a question.
Yes.
Do you have to introduce your insurance to the building owner? I mean, that is pretty risky, right?
So how this works, when we conduct these operations, we technically still own the building. So our drone program is covered through our aviation insurance. So with that, it's covering any type of risk that, let's say for instance, we were to crash into our building, break our own glass. We would cover that ourselves. Because we're self-performing all that stuff.
So you own the building?
Yeah, until it's given, until the owner signs off on it. So during construction, we have full control of that piece of it. But how it works though, before we conduct any type of operation, we have the owner fill out a signature, an authorization form, letting them know that we are flying it and they give us permission to do that. And it also states that within our insurance. So
Do you
we'll cover
need
the
any
losses.
lane closure, road closure?
It depends on the project. So for instance, the one literally downtown here, we actually have control of the lanes, a lane all the way around on 3 sides of the building. So we have control of that. So when we conduct our operations, we make sure that it's safe. And we'll fly it usually on a Saturday or Sunday morning, that particular
so it's a
building.
weekend work.
Yeah, so it is a weekend work, just because of traffic. There is no way I would conduct an operation at noon on a Monday.
Do you need permit from the city? Because I'm doing the same thing, but not drone construction nationwide. But do you need every jurisdiction has a different?
It is, and that you'd have to do your due diligence and verify per county jurisdiction to figure out what requirements they have in place. And then what we do as a company, we actually get a hold of our city agencies, our FESDO department, and we've made those introductions so that they know who we are and how we conduct our operations. So they truly know what we're doing, how we go about our safety. Again, we pride ourselves in safety. So we probably spend more time in our our risk assessment on any project than physically flying it. But once we do that, we will maintain it and analyze it. Yes?
You mentioned the distance, proximity, distance to the building, how you're able to program that in there and the drone will fly that. How is the drone determining that distance? Is there a sensor on board?
No, the operator actually tells the app, this is how far I'm putting you.
Okay.
And then from that, based on what camera you selected, right, and if it's a zoom camera, you would select the zoom level. From that, based on the overlap that you've input as well, it's not depicted here, but it's below the screen, the drone will then set its speed to get the accurate footprint of each photo with the right overlap on the building.
Okay.
Does that make sense?
Yes,
Yeah.
but it's not determining.
It's not today.
calculating real time.
It's not today. When I put a laser rangefinder on Explorer 1, then it will know, or we use an M210, and if we have close enough for the vision sensors to actually pick it up, then we could use that.
Well, that begs my second question, which is, that's a beautiful building, Richard.
Mm-hmm.
Lovely. It's highly reflective surfaces. I don't know what kind of coatings are on the side of that glass, but
Yeah.
I'm wondering, would a LiDAR sensor, how would it affect that in terms of that distance? Because I've seen in many cases in my previous life where shots were going in the building and coming back out,
Yep.
especially in high-rise areas.
Oh, yeah.
So I was just curious about that.
Yeah, no,
That's an expert.
it's a great question. It's something we haven't really solved yet, and I think at this stage of the game where the technology is, we really like he says, he brings his own rangefinder out, and he says, you know what, I'm confirmed that I'm setting this drone down to take off, and it's 100 feet from the building or whatever it is, and I'm gonna enter that in. The drone's not gonna move.
Yep, so how we typically have done that on some of our buildings, we'll actually go out there and take survey points. So again, me and myself, when flying a mission, I love the automation, but at the same time, I need to be cognizant of vertical surfaces and obstructions. So what we'll do, we'll actually get our surveyor group out there, give me northern and eastings, wherever my mission is conducted from one end to the next. I'll physically know where it's an offset of 10 feet, 5 feet. figure out where that's at, and we're able to launch from those locations. And with this system, and if it kind of still maintains those northern and eastings, elevation always changing, we have the flexibility of changing that. Right there, that's a great solution, just to ensure that you're far enough away from the building, and you don't have those kind of bouncing back and forth of the rangefinder.
Piggyback to his question, what's the wind gust for you to fly, the condition? I mean, is it above 7 mile per hour, you will not fly?
It depends. Each emission is different. So what we'll do, we'll analyze that. JJ Pickle building, for instance, on one side of the elevation, it was almost like a Ventoria effect, where we had wind just kind of tunneling down that one elevation. So it varies. It depends. But in our operation, 15 miles an hour is borderline. That's where it's truly up to the pilot to call it quits. Again, we want to make sure we're doing this safe. In rural areas, we've flown almost in 20 miles per hour, but there was nothing out there, nothing at all.
Yeah, you can keep the distance.
On the distance, well, yeah, see, that's on the distance. Anything over, for me personally, when I fly, if it's 7 to 10 miles, I'm always there. And when I constantly have a spotter with me, and they're giving me weather checks, wind checks all the time. And it's one of those things, we're constantly getting wind readings from my observer next to me. He's giving me wind readings, and we're just maintaining
So
that.
you can always set on the drone, if the wind above 15 miles, it will drop by itself.
It's an interesting idea. Yeah, it's something we could look into.
Oh man, I just give you that. Cost you $100,000.
Yeah. Good questions.
Any other questions before we move on?
Cool. All right, so you hit takeoff and you follow along as it goes, just like you do with regular mapping. You got a drone symbol, you see where it's at. You have a live video feed down there in the right-hand corner, which you can expand and take up the full screen. And what you're also seeing is there's dots that are getting placed as it takes a photo. And once it hits the end of the route, it comes back and lands, right? And then once it lands, actually during flight, we're transferring the photos wirelessly via DJI's SDK, so that they're now actually on the app. As soon as you land, you can actually tap the dot where the photo is taken, take a look at the photo on the spot right there in the field. You can annotate it, you can comment on it, you can share it out. So this gives you the ability to get a really quick check, right? Just like Richard mentioned, you don't normally do the entire building at one time. The preference is, as you build, you do each floor or each side as you go. Do a quick check right there in the field, see if there's any critical issues that you may need to take another look at. Once you're done with that, everything syncs back to the cloud, right? And so now, we're good.
Quick question, are you in the process of planning the thing, are you also setting the triggers for the?
No, it's automatic. It's automatic. So we'll set the speed, we'll set the shutter interval based on the camera that you're using and based on the overlap that you set. And it just happens.
The drone's making the decision on when to fire.
Yeah, so with DJI drones, you tend to just tell it, take a photo every X number of seconds. We always use 2. It's the fastest most of the cameras will go. And then in drone adjusts its speed so that that photo happens in the right location. Right.
It would be possible to remote, once it's in air, can you do any remote triggering, or is that not beyond the scope here, beyond the capabilities? And I'm sorry.
You can't really do that because the fastest that camera can actually write the photo to storage is every 2 seconds. So, yeah.
Okay, thanks.
Good question. So then we sync it to, oh, go ahead.
Your analyzed photos on the tablet, is that analyzed as in I look at it, or is it analyzed as you have something running that's analyzed?
In this example, this would be human. In the future, absolutely. We'll have a model that's going to start to do that for you, start to flag things, right? That's where we have to go.
Go ahead.
So will you transfer the pictures back to your app? Are you transferring the original picture or something else?
These are not full res, right? If we try to transfer full res over the DJI Link, it would be too slow, right? So step one is you transfer a slightly reduced version over, you do a quick analysis, and then later you upload the full res photos to the cloud. Good stuff. And here's your interface on our web viewer once they're in the cloud. Same capabilities. You have the full, the full resolution information about each photo. You've got the 3D rendering, so you understand where these photos are taken. That's critical, right? This is how we're also cutting down on that time. Richard's team spent 2 weeks putting this together manually, reading the EXIF, getting a file name and a link to it from Box or wherever, putting that into a hyperlink onto something in Bluebeam. We have all that information. We have it right here. It's very easy to just make that association of the software and instantly have an easy record to access these photos. You know exactly where it was taken on the building because it's got the data. And it'll always be there. And your whole team can go in here and actually do the analysis. So if you're doing a JJ pickle with 2,000 photos, you can divide and conquer. You could have each team member do one side of the building or whatever you need to do.
Yeah, we definitely have each team do one side of the building. Yes, sir.
So as you identify defects or different things you're looking for, maybe select them and tag them, ideally you're developing tools where you can say, look for this type of defect throughout my entire 2,000 image library rather than the first time you might do it manually, like you're saying.
Exactly.
Second time.
Exactly. So this is how we train the model, right? So we're going to actually tag the defect and say what it is.
Yeah.
Have you found any, you mentioned the EXIF file, are you enhancing the metadata, or are you loading in new information in the metadata as you currently those photos so you get
No, I don't think so. Is there an example that you're thinking about though that would be useful?
Instead of carrying along like with file naming conventions and other things to overload some of the variables in the metadata so you can carry forward more specific information about it.
I don't know. We'll have to think about that. Yeah. Any other questions on this?
Yeah, one more. Let's say you send the drone up and it's going to go inspect and let's say it's going to take 100 photos. You're planning it to take 100 photos, whatever. And for whatever reason, you have some technical difficulties and 30 shots weren't taken. Is there any way in the program to say, hey, go back up and grab what you didn't before, or is that next step or next round?
That would be an amazing feature.
Okay.
Ideally, I would devote more resources to catching that sort of as it happens.
Sure.
So that you don't have to go back and do it. But yeah, you would sort of be able to automatically see it visually that there would be no photo markers in that area, and then you would be able to set up a new mission to go up to those areas, cover them again. Yeah.
What makes you pick the pattern, not do like vertical worlds?
We felt like, and Richard, you may have input on this. We felt like the ability to sort of align yourself with the things that you want to see makes more sense horizontally, just because that's the way the floors are constructed.
And that's the biggest thing is when looking at a building, looking at it in a horizontal plane, people familiarize themselves with that, level 10, 7, 8, however, So if you're going into horizontal, all the time when you're looking at all those photos, you're at level 10. As it rolls back up, level 11. So it just worked out a little bit.
You're going through the order of the images that are taken.
Correct.
And you're just saving them.
Correct. So when you're analyzing all that data, you're like looking, like, okay. And then at that point, you could if you understand, you see a column line, oh, that's column B. And that helps you really familiarize where you are with the building versus, vertical. You're looking at that whole vertical, am I at level 3, level, whatever. Especially if the exterior of the building looks so similar and there's no break in materials, it's better to go horizontal. From what we've discovered.
Flat performance, outperforms.
Yeah. No, I don't know. Yeah, and I know of at least one use case where vertical might be better. Like for example, like checking a corner seam the whole way up or something like that. Do you have any others, or are you thinking more just from flight performance?
Flat performance.
Yeah. Yeah. So,
Here's a good example of a vertical flight pad that the folks from the USGS here in Denver maps using an imager, Devil's Thumb or Devil's Tower, from the movie Close Encounters, you know, that they've mapped.
Yep.
They've mapped that whole thing, and instead of doing that pattern, they just did the up and down because it was more efficient for that structure.
Yeah.
They pieced it all together. It's actually a gorgeous 3D model.
Nice, nice.
First one they've ever done for any of their big mines.
Very cool.
Yeah.
Okay, any other questions on this? Good questions, thanks guys. So, Richard, did you have anything else to add to that?
No, I think you covered it.
Good
You
to
did a really good job.
All right, so taking it further, let's talk about some things here. Let's see if I can make this just a quick video here. This is something, the project that we did, Skycatch, DJI, and Hensel Phelps about a year ago.
About a year ago.
When the M200 was getting ready to be launched. This is at the project on 15th Street here in Denver. And I want you guys to kind of notice the pilots are flying manually. They're on the sticks. And I want you to notice how much movement there is, both on the drone that's filming and the drone that's being filmed. And you know, for me, and I'm sure especially for Richard, it makes me nervous to just watch it moving around that much, that close to that glass, right? So it's another reason to think about, okay, why are we automating this flight, trying to do it in a way that's very consistent and reliable and precise. Additionally, how we think about some of the things that Richard brought up with respect to wind, the distance, the GPS, what are other obstacles. We need to automate all of those variables out to make sure that you can just go fly and be safe. Do you have any more to add to
Yeah,
that?
no, I think you hit it. That was the key thing when flying this building, when we did that, is just being cognizant of how close we were to that building. We've already installed this glass, and for us to damage it and go back and replace it was a big concern for me. So moving forward, definitely, you know, to Patrick's point, we need to make sure that we have something that actually locks in those positions so that we know we're flying a vertical consistently, and we're also, you know, flying safe. We're far enough away from the building so that thing's not in and out of that building. And we actually had the pilot here that flew that. He walked
Yeah, he
out.
stepped out. No, the DJI pilots were amazing. They didn't run it. They were incredible. They didn't run anything or even come close.
Yeah, best pilots out there.
So the RTK on that didn't help?
We didn't have it on.
They didn't.
Yeah, we didn't have it on for that.
These were very early units. They didn't turn it on.
Yeah,
Yeah.
But my goal is we need to go back and run a thermal of that building within a month. So I'm gonna see if we can work out.
They got a few of those.
Yeah.
So, Richard, I don't know if you want to if there's anything else to hit on the best practices and learnings, at least for like the first 3 bullets there.
Yeah, I think, again, best practice, wind, right? If you're going to fly a mission like this in a urban environment, be cognizant of wind conditions, be cognizant of how close you are when flying, because everyone who flies knows if you get hit with a downdraft or a gust of wind, that's going to push it. You lose GPS, it's going to push it up against a building, or a structure, any structure. It could be a bridge or a building. So be cognizant of that. And just understand, you know, if you're doing a vertical building, understand your floor offsets. That's truly important. What we found by flying and figuring out a pattern manually, it's helped us analyze the data. So just kind of really plan your missions ahead of time. And probably the first building you do, you're not going to get it right, but you're sure going to get it right the second time because you're going to realize you missed something. Zoom lenses, that actually helped us out a lot. On a lot of our projects, I'll actually fly further away from the building and zoom in with my zoom lens and actually still get the quality we're looking for. So if you have that option, I would recommend that because you're further away from the building and still capturing the data you want.
Yeah, and so on the last point, and so there was a question about this earlier. Yeah, if you have the opportunity to use DRTK for one of your N600 or 200, definitely. If you can, in this example, I flew a P4P manually to do some inspection, had satellites when I started the pass across the building, and by the time I got halfway through, I had no satellites or not nearly enough to do anything. And it was very, the drone was moving a lot. It was actually pretty scary. So, but there's a clear space nearby that building where within range of the DRTK unit, if I had had one, I would have set that up there and been in great shape. In addition to that, if you're using a Skycatch drone, you can also use our Edge 1 to do the same thing. Tom Zaderman here from Skycatch will be giving another workshop tomorrow about mapping on the edge and talking about use cases of Edge 1. And this is one of those that we're going to help with vertical inspection as well. And if you don't have those solutions, then the GPS challenge environment, like I kind of mentioned in the keynote, we're going to have to work on some other solutions. I think, okay, last thing here, we're slightly over, so we'll go through maybe quickly, Richard. We just wanted to talk about, and we also wanted to poll the audience. You guys are all sitting here thinking about this. What are some additional use cases? You can run through those, and we'd love to hear from you guys.
Real quick, one of our biggest things was looking at the in-bed. So every time we hung that glass, we'd have to go in there and weld in-bed plates. What was really important for us is running the drone up, making sure that we had those in-beds in the right location, make sure that they were welded properly before we started hanging glass. That was a really good case use for this particular building. Also looking at flashing details, looking at the brake metal that went on the glass after we installed it, and make sure that was fastened and secured, make sure that the weather strips were in there. So that's how we're able to use drone technology. That's it for me.
Anybody thinking about any other use cases that we haven't talked about that you want to just share?
I have another question. Do you find yourself using more real-time, like looking at thumbnails coming down? Like what's your ratio from infill real-time looking at images versus looking at analytics layer processing?
It's both. Real time, I definitely need to make sure that I'm in the right location. Because visually, I visually have an eye on the drone, so I know where it's at. And looking at it, I know exactly where it's at. So that's, for me, it's a good key, knowing that I'm in the right location. And then if I need to make an adjustment, I'll make that adjustment then. So I do both.
Any other questions? Oh.
So this methodology produces a tremendous amount of image data. In your company, you already manage AutoCAD and digital layouts, that sort of thing. Is this like easy for your IT and your staff to do your underlying architecture to pick up, or is it kind of?
Well, so how we've set this up, we do a lot of we're one of the largest laser scanning companies out there. So we already had a method in place for that. So we've taken that same server concept and implemented it for our drone process as well.
It's a really important topic. Again, theme of the conference, scaling, right? And you're going to keep having more and more and more data. That's a good problem to have, but yeah, you have to have a plan for it. And these guys, like I said, I told you, these guys have it locked. If you have any questions how to scale out your organization, talk to Richard. He's the man. Any other questions? No? All right. Hey, really appreciate it, guys. Thank you so much for coming.